Hey everybody, this is Mrs. Slauson. Here is the good news. Your video notes for this week are actually going to be pretty short. We only have one thing to talk about. And while you'll need to get your your yellow packet out and go to page 11. And then the other thing I'm going to need for you to do is you're going to want a calculator. Again, if you haven't gotten the graphing calculator, I really need for you to get that graphing calculator. I'm just going to be using a regular calculator for today. And then the other thing I'm going to explain to you when we're done is I'd like for you to put an app on your phone for when I see you in class. It's called Desmos, and I'll show you that when we get done with these notes. So you want your phone. I'm pretty sure it's an app. I don't know if we go to the browser or not. Yep, it's an app. So we'll do that in a little while. So it's going to look like that. All right. So I'm on page 11, and the last thing we need to talk about in the week 5 videos, we talked about how you interpret graphs, how you read a graph. And so the last thing we need to add to that is average rate of change. And you are, if you just read at the top, and I'm sorry this is a little dark for you to see, when you work with average rate of change, that is the same as slope. Okay, so when you work with a straight line, so linear functions, you did find the average rate of change when you were asked to find the slope. And the slope on a line has a constant rise over run. So when you get that straight line, like down here, to get from one, they call them lattice points, to the next lattice points, they're just the easy points to recognize. It is constantly the same rise over run. So I'm going to rise 2, run 1, rise 2, run 1, rise 2, run 1, rise 2, run 1. So it's always the same in a line. So what we're going to do, since we're working with different shapes in Algebra 1, again, we'll work with lines, we'll work with quadratic functions, is we're going to still find the slope, this average rate of change. But what will happen is what we want to do is instead of seeing, what's the rise over run from this easy point to the next easy point, if you notice, this is rise 1 over 1, but then to get to the next lattice point, it's up 3 and over 1. So that's not the same. So what we're going to do is average that out. So basically what's going to happen is I'll be making, a straight line connecting this nice lattice point to this nice lattice point and just finding out this overall route that it takes. So I don't know if you've ever heard of the saying, as the crow flies. Instead of going this route, we're going to go straight, because a bird can just fly straight over. It doesn't need to manipulate through roads and stuff like that. And so to get from here directly to here, I'm going to rise 2 over 1, rise 2 over 1. And so I kind of take that curve and make it a straight line and then find the straight line, the slope of that straight line. So what we're going to do is we are going to be finding the average rate of change, which is just your slope. And one thing to note, an average rate of change does need to be simplified until the denominator is 1, because a rate is always out of 1. And so an example is when you get gas, this is $2.40 per 1 gallon. So we always got to get it to 1, and that's why we might need our calculator to do some of that division. So just remember of how you find slope. You need 2 sets of x and y coordinates, 2 sets of ordered pairs, and you will subtract the y values as your numerator, and then you will subtract the x values in the same format in your denominator. The only step now is we're going to go one further step and put it over 1. So let's just practice. I'm going to find the average rate of change between this point and this point. And so what I want to do to find my slope, and sometimes you also see it with these triangles, it's called delta. It just means subtract, find the difference. And so what I'm going to do is just take a look at these y values, the -4 and the 5, and decide, all right, how do I want to subtract these? And so I want to subtract them the easiest way. So I always like to take the big number and then subtract the small number. So when I decide who's the little guy, like -4 is the little guy, so I'm going to do 5 minus, because it's always subtraction in it, and then my little guy is -4. Now, since I'm subtracting 5 minus -4, when I subtract my x's and put them in the denominator, I have to follow that same format, and that's why they have the little 2 and the 1. And make sure that you subtract 2 or sorry, that you take 2 and subtract -3. So that marker is not going to make it much longer. Hold on, I got to find something else to write with. Okay. So that's what I'm going to do. I'm going to do 2 and subtract the little guy, -3. And I'm not doing that because that's the way I want to do it. It's because I have to do it that way. So again, I'm going to subtract. Subtracting, I don't like subtracting, so I like to do this process where I call adding the opposite. So I change that into addition, that's adding. And then I take the opposite of -4, and that's a +4. So when I'm ready, this actually just became 5 plus 4, and I get 9. And then when I subtract here, again, I don't like subtracting, so I'm going to turn it into addition. And then I move, to the term behind it, and I take the opposite of -3, and that turns it into a +3. So this becomes 2 plus 3, and I get 5. So this is 9 over 5. But again, we'll want to take our calculator, and I realize you can, there you go. And I want to take 9 and divide it by 5. And make sure you divide the right way. Division only works one way. So 9 divided by 5. And I get this decimal. If you by chance get a long decimal, we always go 3 numbers behind the decimal. So it's 1.8 over 1. And again, just a reminder, this was me putting the y values on top and the x on the bottom. All right, so I kind of explained this already. And now let's go down here. So we're going to complete the table for the quadratic function, and then we're going to find the average rate of change from 0 to 7. So what I need to do is just take these inputs, these independent, these x values, put them into my function, which we did in the week 4 videos, and do my math. So just a couple of examples. So again, if this is x squared minus 4, I'm giving you x, you're going to do math, and you're going to find the y. And remember, y and f of x are the same. They are interchangeable. All right, so that's why you're not going to see the y all the time. Sometimes we'll switch it with this function notation. But anyway, I'm going to put 0 in there. 0 squared, take away 4. I do my exponent, that's 0. And then 0 take away 4 is -4. So when I'm done, if my function, if x is 0, gives me an answer of -4, or y is -4. So I'm going to do the same for 1. 1 squared, take away 4. 1 squared is 1, take away 4, and I get -3. I'll put 2 in, so 2 squared, take away 4. That's 4, and 4 take away 4 is 0. And now 3 squared, I know some of you are like, move it, Mrs. Lawson, I already know this now. That's 9. 3 squared is 3 times 3. 9 take away 4 is 5. I'll put 4 in there, so 4 squared, take away 4. 4 squared is 16. Remember, it means 4 times 4. It's not 8, and I get 12. And then last, I'll put 7 squared, and 7 take away 4. There's 49, take away 4, and we get 45. All right, what we want to do is to see how this shape has averaged out in a slope. So again, if I graph this, it would be this U shape, and I don't have a straight line where I can just count up, over, up, over, up, over type of thing. So we're going to have to find the straight line basically that connects, let's see, from 0. So we're going to use this point to this point. All right, and I know that because they told me those x values, and then we did the math to find the y values. So up in here's my fraction for average rate of change. I start with the y, so I'd like to take the big guy and subtract the little guy. So 45, there's subtract, and my little guy is -4. And then since I'm subtracting this way for the y's, I will subtract the same way for the x's. So 7, take away 0. Again, I don't like to subtract, so I add, and then I take the opposite of -4, and that's a +4. Again, it's add, use my pencil, the opposite, I use my pencil again. So now I get 49, and I don't mind the subtraction, I can do that. And again, you always want to divide, so 49 divided by 7, I don't need my calculator, and it's 7 over 1. Okay, for now we're going to keep the denominator because when we start to put this in context, we need a denominator, even though 7 over 1 is still just 7. All right, so let's put this in context. So remember, average rate of change, we're going to abbreviate this as AROC. And again, I apologize that this is dark. what we're going to do is we're going to find our average rate of change, and then we're going to determine what the y value is in context and the x value is in context so that we can put a description to our slope in context. So below is a graph representing the population of Nashville since 2010. So first I just want to look at the graph before I do anything else. I'm going to see that my years are since 2010. I technically do not need these years because time is not negative. So this, here's my origin, is 2010. This 1 year after is 2011, 2012, 13, 14, 15. And then if I look at the population, it's starting at 10,000. So when this data was taken, the population in 2010, the population of Nashville was 10,000, which I don't think it was that small. But anyway, what does this point mean in context? So 0 and 10,000. So again, 0 is the years, and that's since 2010. And so since it's no years since 2010, that is 2010. And the 10,000 is our population, because that's the y value. So what does this mean? That is not an acceptable answer of what I just wrote. So explain what it means in context. And again, I see this is a dark picture for you. It just means that in 2010, the population, you write it as a sentence, is 10,000. That's not the only way you can write it, but that's how I'm going to write it. So now I want to find the average rate of change. What I want to know is how did my population change on average every year since 2000 to 2012. So again, this is X, 0 is 2010, and 12 is 12 years since then, so that's 2022. So I'm going to take my slope, and 16,000 and 10,000, I like to take the big guy and subtract the little guy. Be careful you get all your zeros. So I'm going to draw this arrow, which means I'll have to subtract 12 and 0 the same way. So I'm going to subtract, I get 6,000, here I get 12, and if you don't know what 6,000 divided by 12 is, don't worry about it, you turn on your calculator, which I'm doing as well, and when I'm done, I get 500 over 1. So now we've got to explain it in context, and this is the toughest part. So in context means, how do these numbers relate? So remember, your entire numerator is y. And when I look at the y-axis, that's the population. So this 500 is my population. And then when I look at the denominator, that's the x. Everything about it is x. And when I look at the x-axis, that's the years. And then this is a rate of change. This is how the population is changing. So what I'm going to say, the population, or the Nashville population, is increasing. So increasing versus decreasing. This is increasing because the slope is positive. So the Nashville population is increasing 500. Oh no, there it goes. It's dying. 500 people every year, 1 year. So again, what's happening here is, people come and go from states. So a lot of people might move in, but there's also people that are moving out. But overall, every year, if they average out the people moving in and out, the population's increasing by 500 people every year. All right, let's go to this picture down here. So again, always read what this description is. Always look at your scale. So in a study of the activities of dolphin, a marine biologist made a 24-second video of a dolphin swimming and jumping in the ocean with a specially equipped camera that recorded one dolphin's position with respect to time. So T represents time in seconds. That's our x-axis. And if you look, they're numbering by fives, but there's also all these little lines. So actually each little line is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And F represents the dolphin's height in respect to the water. So if I look on the side, this is the height in feet. So my y-axis is height and my x-axis is time. So let's go through. The 0.60 is on the graph. Explain what it means. So again, 6, that's your x value. And so what you want to do is the axis is describing the time in seconds. And then you got your y value, and that's 0. And then again, this is just feet. So if you think about it, I guess I'm assuming the camera has started, and it's catching that the dolphin is jumping up, goes in the air, then it hits this, and this is the water, and now it's underwater, comes around, gets momentum, jumps up out of the water, and then maybe the camera shuts off. So it doesn't have that much footage. But it just means after 6 seconds, the height of the dolphin, is 0 feet, which doesn't quite make sense when you think about that. So it just means it's probably, let's see, what this picture is saying, it goes up and now it's entering the water. So it's entering, and I don't have a lot of room to write water, so I'm going to put H2O for water. All right, going back to the previous section. So again, I realize this is dark. I do apologize. I don't know if I can make it any brighter. Does that help? I'm shining a light on it. I don't think it's really helping that much. Okay, so the next one is on what interval is the dolphin's height decreasing? So there's a couple things we had talked about in the last set of videos. Sorry, I'm just messing with my phone here real quick, trying to shut that light off. Okay, so we talked about increasing and decreasing. So here the dolphin's height is increasing. It hits the top, and then it starts to decrease this whole segment until it gets to a low point, and then it starts to increase again until it gets to a high point, and then it starts to decrease, and then the camera shut off. So on what interval is the dolphin's height decreasing? So now what I need to do, since they're asking about this, is kind of mark those important points. So this is 0, 0. This point, if I count over, is 1, 2, 3. And then my y-axis is going up by, it says 20, but it's actually by 5s. 5, 10, 15, 20. So I think this is about 315. I also told you I want you to mark the x-intercepts. That's 6, 0. I need to hit this low point, so that's 10. This is 11 seconds. And again, the y-axis is going by 5, so if this is negative 40, then this is probably negative 45 and negative 50. And then I have another x-intercept of 16. I hit a high point of 20. And, this is kind of in between 20 and 25 because this is going by 5, 10, 15, 20. So somewhere in between 20 and 25, I don't know, I'm just going to say 23. And then till I get to this, and this value is 24 and 0. So again, it's always good to mark those important points. All right, so from here, on what interval is the dolphin's height decreasing? Well, it's actually happening twice here. So it's between two values. And then it's happening another again, and it's in between these two values. And remember, that is how you write between. So if I look at this one, now I'm going to put the x values. So it's decreasing from 3 seconds all the way down to 11, so between 3 and 11. And then it's decreasing again here from 20, and then it stopped the graph at 24, so from 20 to 24 seconds. All right, find the average rate of change from 5 seconds to 15. So again, these are the x values. Time is x, so I will need to look at my graph to get their corresponding y values. And that's the first time we've had to do that. So if x is 5, then I'm going to go up, and this is, again, my y-axis is going by 5, so that's 5 and 10. And then I want to go to where x is 15, so here x is 15, and again it's going down by 5, so 5, 10, 5, 10, maybe negative 15 feet. And now I'm going to subtract. I will put the y's on top, so I like to take the big guy and subtract the little guy. And since I'm subtracting my y's in that direction, I'll subtract my x's in that direction, and x is the denominator, so 5 take away 15. I don't like that subtraction, so I will be adding the opposite. So I'm going to change this from adding, and then the opposite of negative 15 is 15. And then 5 take away 15, I think I can handle that one in my head. So 10 is really adding 15, and I get 25. And 5 take away 15 is negative 10. And then again, I want this over 1. So I divide 25 by negative 10. And it's negative 2.5. So I'm going to write that down first here. And again, this has to be explained in context. So again, I need to remember that the entire numerator was all about the y's. And your y's represents the distance, the height of the dolphin. So this is feet. And then the x value is the x-axis, and that was all about my time in seconds. And again, this is all about the change of the dolphin. So the dolphin is decreasing, and how do I know it's decreasing? Because it's negative 2.5 feet every, can't spell, second. That's one way to say it. Okay? All right, now it's there. Is that it? Let's just double check. Okay, so let me see if I want to catch anything else. Hold on, I thought I had a little head note in my mind, but I don't think I do. So, all right, so what is your practice going to be? Your practice, which you should have already done, and this will be listed in step 2, but let me just tell you, once I get there, hold on, is I want you to go to page 14, the last page in your packet, and you should have already done this, right? Or actually, well, now I can't remember if I signed this. I don't have it in front of me. But I want page 14 done. So whether you started page 14 or finished page 14, maybe I started it, I'm not quite sure. But page 14. So you're going to use this graph. Again, I would suggest you mark those important points. So where it starts, any turning points, and where it ends. All right, and you'll want to write those x values. So that that's 30, 0, and that's 15, 7. I'll let you do the other two. And again, you're going to evaluate. So tell me what this is worth, and then you're going to explain what it means so you can see the first answer. And then you're going to do an average rate of change, and then just average rate of change practice down here. And again, I expect all those denominators to be 1. And if you get a long decimal, I want you to go 3 numbers behind the decimal. And that's it. That is our videos for the week. The next thing I'd like for you to do is, if I can find my phone, I don't know where I set it, is I would like for you to go to your app store and find the Desmos app. So it's kind of hard to see this color, but it's green. You're going to, I just have to download mine because it's already been on there. And I want this app on your calculator for when I see you next week, because we're going to be using this. For now, it's probably just going to be a little bit easier for sake of time to use this app versus the graphing calculators. But you still need to get your graphing calculator, all right? And I think at some point I'm going to make that as an assignment, because again, you can rent it, and you can rent it for free if you check the right box on the rental form. That's it. I will see you in class.